The test statistic of z equals 0.82 is obtained when testing the claim that the population proportion is greater than 0.64. This is a right-tailed test, and we're going to use a 0.05 significance level, and then we're going to complete parts A and B. The first thing we want to do is find the critical value or values. So let's just revise and write down the given information that we have. So we're going to state the claim and the opposite of the claim. So we know that the claim is given, okay, and that claim is the following. We know the claim is that the population proportion is greater than 0.64. And therefore, the opposite of that claim is going to be the population proportion is less than or equal to 0.64. So now that we know that, we're going to go ahead and then determine in step 2 the null and the alternative hypothesis. Now remember that the null hypothesis always contains the equality, and then we want to also find the alternative. Well, the equality is located in the opposite of the claim, so therefore the population proportion is going to equal 0.64, and therefore the claim is going to be the alternative where we have the population proportion is greater than 0.64, which is exactly what it says up here. And therefore, since it's greater than, we know it's going to be a right-tailed test. Okay, and again, we're using the alternative hypothesis to determine that. And now we're going to select the significance level. Well, the significance level is given to be 0.05. And then also, we have the test statistic, which is given to be z, which is equal to 0.82. Okay, now that we have that information, now we wanted to draw the curve and label in order to find the critical value or values. So the first thing we need to tell ourselves is that we know it's a right-tailed test. So if it's a right-tailed test, that means we're only going to have one critical value. And that critical value is going to have an area of 0.05. So we want to determine what is that critical value. Okay, so what we can do is draw the bell curve. Okay, we know we have a mean of 0, and we know it's a right-tailed test, so we're going to shade over here on the right. And then we're going to find that critical value over here on the right. And that tells us that the area here is 0.05. And then the area that's shaded represents the critical region. Okay, so now in order to find that critical value, we know that the value of that critical value, since it's shaded to the right, has to be greater than or equal to, and we have an area of 0.05. So let's go ahead and use StatCrunch to determine that critical value. So we're going to go to Stat, Calculators, and then go to Normal, since it's a z-test statistic. And now what we're going to do is we're going to make sure this is greater than or equal to, and then we're going to put in the area of 0.05 to determine what our critical value is. And our critical value, rounded to 2 decimal places, is equal to 1.64. So we only have one critical value, and that represents 1.64. Let's go ahead and put that in here. So there's only one critical value, and that's 1.64. Okay, now we have to determine whether we reject the null or fail to reject the null, and we need to use the test statistic to determine that. So the test statistic that we have is given to be z, which is equal to 0.82. So let's go ahead and write that. So the test statistic is z, which is equal to 0.82. Now it's to the right of 0, but it's to the left of 1.64. So here we have 0.82. And if you notice that the test statistic is not in the critical region. And since it's not in the critical region, then we would say that we would fail to reject the null hypothesis, because if the test statistic is not in the critical region, we would fail to reject the null. So therefore, this would be our answer. We would say the null hypothesis should not be rejected since the test statistic is not in the critical region. So we would say C, the null hypothesis should not be rejected since the test statistic is not in the critical region. Checking our answer, and there is our result.